Ultrasonix provides its research and OEM customers with different software development kits or SDKs. The kits can be used to utilize our hardware and software for development of new imaging methods as well as customization of the existing imaging methods for different applications. The SDKs are C++ libraries which can be used in your own C++ software to access the Ultrasonix hardware and software resources. As distributed C++ libraries, the SDKs come with include files or .h files. These files contain the declaration of the available functions in the SDKs and their prototypes. You can understand from the prototypes how many parameters each function gets as inputs and outputs and what are their associated data types. The include files are used during the compiling step of C++ build process to ensure that all the function calls are made according to the prototypes. The .h files for each SDK can be located inside a folder called inc under each SDK's own directory. There are some common .h files located in the global or UMC directory under the root of the SDK too. The SDKs also come with library files or .lib files. These files contain a list of all the exported functions and data and in which dynamic link library or DLL they are located. The library files are used during the linking step of the C++ build process to ensure that the final executable file knows where to look for the binaries for all the functions it uses from the SDKs. The .lib files for each SDK can be located inside a folder called lib under each SDK's own directory. The SDKs also come with dynamic link library files or .dll files. These files contain the actual binaries of the SDK functions, which means they contain the code that CPU can execute for each function. These files are not needed during the build process, but when you want to execute your program, the executables should have access to these DLL files. All the DLL files are inside a bin folder under the root of the SDK package. Each of the SDKs provides a different set of functions or level of control to its user. Here is a short list of the SDKs and their philosophy of existence. The Alterius SDK is used to connect to the exam software, change the parameters, and get the images in real time through a network connection. Texo is used to access the sequencer hardware, to program custom sequences, and to acquire data in real time on the Sonix systems. Porta is a scaled-down version of the exam software which can be used to rebrand the ultrasound system, for example for OEM customers. The Propello is built on top of Porta and gives more control over the motion of the 3D probe. Amplio is purely an image processing SDK which does not require the ultrasound hardware and can run independently. It processes RF data and generates B-mode images. Impero is used to access the console of these Sonix systems, like the different buttons, dials, and sliders located on the console. Fluctus is used to access ECG signals. Now I move on to some details about the hardware of Ultrasonix systems. This is a high-level block diagram of the hardware of a Sonix system. The transducer is connected to the probe connector. The signals from the probe connector are fed to the analog front-end, which deals with the analog channel data. The digital beamformer generates and processes the digital data that are sent to and received from the analog front-end. The sequencer controls the digital beamformer by sending the transmit and receiving the received data. The analog front-end, digital beamformer, and sequencer are physically located in a module called the main module. In Sonix touch platforms, this is housed inside a door which is hinged to the housing of the system, which contains the motherboard and other components of the PC. The sequencer communicates its data with a PCIe card, whose main job is the transfer of the data between the PC and the main module. The PCIe card is placed inside one of the PCIe Express slots of the motherboard and connects to the main module by two wide ribbon cables. The Ultrasonix software, which runs on the PC, receives RF data, does the signal and image processing, and sends the images to the display. It also reads the commands from the console and interprets them for the PCIe card. Note that this diagram is related to version 6.x of our software. In prior versions, envelope detection was also carried out in the hardware, and therefore in addition to the RF data, envelope detected data was also transferred from the hardware to the PC. The main module and the PCIe module both have FPGAs and other programmable hardware on board. Therefore, in order for these devices to function properly, their firmware needs to be uploaded to them. The Ultrasonix hardware has evolved and been upgraded since we shipped our first product to our customers. Therefore, there are different versions of the main module and the PCIe module. Each of these versions requires its own version of the firmware. It has been our policy to support our older hardware through its life cycle. Therefore, most of our software upgrades support legacy hardware. The software upgrades come with different versions of the firmware targeted for the different versions of the hardware. Therefore, when uploading the firmware by the software, it should be pointed to the correct version. Note that it is not possible to use the system before the correct version of the firmware are programmed by the software. This discussion emphasizes the importance of understanding the versions of the main and PCIe module that are inside your Ultrasonix system. The exam software has a module that automatically detects the versions of the main and PCIe modules and stores them in the registry. This is done only the first time that the exam software is run on a system. After that, the exam software only checks the registry of the system to figure out the correct versions of the hardware. You can do the same to understand the versions of the hardware inside your system. To access the registry, click the Windows Start button and then Run. In the Run command line, type regedit. This brings up the registry editor of Windows. Go to hkey_current_user/software/ultrasonix/exam/system/revisions. You should be able to see the revisions for the main and PCIe module here. If you are curious as to where the actual firmware files are located, in the exam software installation folder, the firmware files are located under ultrasonix/exam/firmware. In the SDK, they can be found under sdk/texo/dat. The firmware files are .bit files, and here is a short list of them. The X's are the revision numbers. Also, in the same folder, you can find a firmware.txt file which explains what each of the firmware files are. Here is a snapshot of the inside of this file. This slide concludes my discussion of the hardware.